All right, now we have geometric series. Geometric series, of course, is going to be the sum of a geometric sequence. So we can write this in our sigma notation. So notice we can just write the sum of all the terms. All those terms are given by our general formula. So within our sigma notation, we're using the general form for the sequence, not the series formula. The series formula is what we're going to end up developing. So let's look at, again, this basic one. So we've got a u1 of 1 and our r value is 2. So the sum of the first 3 terms, I'm going to get 7. Sum of the first 4 terms is 15. And then I would get 31 and then 63. So notice that these are all almost powers of 2. So this is 2 to the 3rd minus 1. This is 2 to the 4th minus 1. This is 2 to the 6th minus 1. So our hypothesis could be that S sub n is r to the n minus 1. But if I just look at the next common series of 1, 3, 9, 27, so notice my S sub 2 would be 4, and 4 is not 3 squared minus 1. So that doesn't work. But these are the sums that I'm adding. Sorry, these are the terms that I'm adding. So notice I could factor out my u1. So S sub n is going to be u1 times 1 plus r squared plus r to the n minus 1. So maybe my hypothesis is going to be that I need a u1 in front of this. Well, if I tried S sub 2 is equal to 4, which is my first term, 1 times 3 squared minus 1, that doesn't work either. So we need something similar, and what we have is that r to the n minus 1 factors. So this was our hypothesis, and it was wrong. But let's build off of it. So note that r to the n minus 1 factors into r minus 1 times 1. So generally we would say r to the n minus 1 is normally the order we would put it in, plus r to the n minus 2 plus, and we would continue all the way down until we just got to r squared, r, and 1. So this, maybe you knew, maybe you didn't know, but this is the way we factor r to the n minus 1. So now I've got my u1 times this. So if I multiplied both sides by u1, I would get u1 times r to the n minus 1 equals u1 times this quantity. If I put this in ascending order, I'm going to get 1 plus r to the n minus 1. I still have this r minus 1, but this is what I want. This is the sum that I'm looking for. So I'm going to take this r minus 1, which would normally, well, we'll write it down. So we multiplied both sides by u1, but now I'm going to divide by this r minus 1 so that I can get my S sub n. So we divided this out to the other side, and now this is my formula for S sub n. So for a geometric series, I end up with the formula u1 times r to the n minus 1 over r minus 1, or if r is negative or a fraction, then I tend to write it in this form. These are absolutely equivalent. You can use either one. The only caveat is that r cannot be 1 because of course we can't divide by 0.